Thanks for watching this video. This is Mr. Bowman, and in this video we're going to talk about solving quadratic equations by factoring. So we need to talk first about what quadratic equations are. A quadratic equation is any equation of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. Here's just one example of a quadratic equation. 4x squared minus 5x plus 2 equals 0. Now this is a quadratic equation because it is of the form where I've got some number times x squared and another real number times x, and those are added together. And then I've got another term that is just a real number term. So in this example, this number 4 is my a. The number b is the negative 5. Like that's the number that goes in place of b. And the number c is 2. So any equation that has that property is called a quadratic equation. And the reason it's important to study these on their own is that you can't solve these like you solved other linear equations earlier in algebra. You can't really solve this equation by getting the x term by itself on one side. So we're going to have to look at some techniques that will solve this. Okay, we're going to play a game real quick. I'm thinking of two numbers and their product is 24. And I want to remind you that the word product here means to multiply. I'm thinking of two numbers that multiply together and give 24 as the answer. What I'd like you to do is I'd like you to pause the video right now, and on scratch paper or something or off to the side, I want you to jot out as many different possibilities as you can think of for what my two numbers might be. Go ahead and hit pause and try it. Okay. I'm willing to guess that you found maybe these options. My two numbers could be 1 and 24. Or maybe they're 2 and 12. Maybe 3 and 8, or 4 and 6. Those all are options. But are there others? There are. Here's some more options that work as well. 48 and 1/2. What about 240 and 1/10? Or even pi and 24 over pi. Multiplying all of these sets of numbers together would give me 24 as well. The thing is, if I'm multiplying two numbers together and their product is 24, there's no way for you to know what one of those numbers has to be. If I told you one of the numbers, you could tell me what the other one would have to be. But there's no way to know for sure what one of them must be. Let's play the same game now, and let's use 0. I'm thinking of two numbers whose product is 0. And again, I want you to pause and write down as many different possibilities as you can of what my two numbers might be. Did you get them all? I don't think you can get them all. Here are a few of them that I jotted down. 0 and 5 would work. 4 and 0. 12 and 0. Negative 6 and 0, 0 and pi. They could even both be 0, 0 and 0. Do you see what's different about this case of the game? If I'm multiplying two things together and their product has to be 0, what does one of them have to be? One of the things I'm multiplying has to be 0. And we're going to take advantage of that fact and use that idea to solve some quadratic equations. So here is the 0 product property, and this is essentially what we just looked at on the previous screen. If any product of two factors a and b equals 0, then either a equals 0 or b equals 0, or both. So here's what this means. If we can factor a quadratic equation and write it as a product of two factors, then I can use the 0 product property to find solutions to that equation. Let's look at a couple of examples. Here's a quadratic equation. Let's see if we can solve it by factoring. The equation is x squared plus 4x minus 21 equals 0. I want to see if I can factor the trinomial part of the equation. Can we factor, like with the box, the expression x squared plus 4x minus 21? If I can use the box to factor, something you're hopefully already pretty good at, we can use that zero product property to finish the problem. Well, to factor x squared plus 4x minus 21, I know the x squared belongs here. I know the negative 21 goes here. I recall that x and x must be what's needed to multiply to get x squared. What are my options for multiplying two numbers and getting 21? It's either 1 and 21 or 3 and 7. And the minus sign tells me that the signs of these numbers will have to be different. Can I figure out which of these sets of numbers has a difference of 4? Yeah, it's this one. So I need 3 and 7. Can I also figure out which of those two numbers needs to have the negative sign with it to get positive 4? It needs to go here, doesn't it? The negative 3 and the positive 7 to give me positive 7x and negative 3x. And what I hope you'll remember is that the outside of the box tells you what your factors are. The left side of this equation can be rewritten as a product of x minus 3 times x plus 7. And that equals 0. And here's where we have a product of two things now that equals 0. So the zero product property says that if x minus 3 times x plus 7 is 0, then either this factor equals 0 or this factor equals 0. X plus 7 equals 0. And I can solve both of these equations using the addition and subtraction properties of equality. If x minus 3 equals 0 and I add 3 to both sides, I get x equals 3. If x plus 7 equals 0 and I subtract 7 from both sides, I'll get x equals negative 7. This equation has two solutions, 3 and a negative 7. And I can show you that they both work. If I let x be 3, 3 squared is 9. 4 times x would be 12. 9 plus 12 is 21. And 21 minus 21 equals 0. The same is true for negative 7. If x is negative 7 squared is 49. 4 times negative 7 is negative 28. So 49 minus 28 is 21, and 21 minus 21 is 0. Let's look at another one. Let's see if we can solve 2x squared plus 5x minus 12 equals 0. Let's see if we can solve it by factoring. Well, the 2x squared belongs here in my box to factor, and the negative 12 goes here. You know, for 2x squared, I think my two factors have to be 2x and x. There's no other way to break the 2 down. And I'm going to be looking for factors to multiply and get negative 12. It could be 1 and 12. Signs are going to have to be different here, aren't they? It could be 2 and 6, or it could be 3 and 4. Remember that I'm seeking to get positive 5 out of the sum of these two boxes. Remember that this one's a little bit more like trial and error. You see which one we're looking for? Let's try the 3 and 4. Maybe we'll get lucky. I'll try 3 and 4. I'll put the 3 here. I'll put the 3 here. Let's go 4 and 3. Is that one going to work? 2x times 4 is 8x. 3 times x is 3x. You know what? I think I lucked into getting the right one on the first try. I know the signs have to be different, which meant that if I make this negative, this would be negative 3x. And for this positive, that's positive 8x, and that gets me what I need, doesn't it? We made it. So my factors are 2x minus 3 and x plus 4. That equals 0. Since I haven't factored now, the zero product property says that, well, either 2x minus 3 is 0, or x plus 4 is 0. If 2x minus 3 is 0, I can subtract 3 from each side of the equation and show you that 2x equals negative 3. And if 2 times x equals negative 3, I can use division to show you that x has to be negative 3 halves. Now you could write that as a decimal if you wanted to, but there's no reason why you can't leave that as an improper fraction. This one's a little simpler to solve. If x plus 4 is 0, I think x has to be negative 4. What you're going to find is that many, not all, but most, quadratic equations will have two different solutions to solve them. Thanks for watching.